All right. Okay. Oh, lighting. Projector low, frost. Oh my goodness, what a start to the day. Or what a start to lecturing anyway. This is the real lecture question today. You should answer it right now. If you weren't exactly on time, as long as you were here before the question's up, I'm fine with that. I made extra sure that I was on time here today, and then of course I have every technical issue imaginable. As soon as I plugged into the projector, my laptop decided to restart like it did once before, and now it won't connect to the podium at all. So I don't know if it's my laptop's issue or the podium. I don't know. But I'll have to present from the in-room computer here. But yeah, this is the real lecture question. This was the intended lecture question too, but technical issues kind of fumbled the delivery here. So I'll wait until everybody answers the question. Hopefully the Wi-Fi plays nice. My Wi-Fi was pretty slow too, just to add on to everything else. And then once everybody gets the question in, we'll go on with lecture. What the? There's a fan that's absolutely melting in here. Something's melting in these electronics, and I don't know what it is. All right, so everybody got this in? Anybody need more time? Nobody needs more time? All right. Okay, let's do this. Don't need this anymore. Don't need this. View full screen. And this, I'll use this keyboard. Unless, actually, let me try one thing. I wonder if this will recognize my clicker. Holy shit, all right. One thing went right. So today we want to talk about ABR. That's the thing for today. We're not going to get to ABR until like halfway through the slides, but that's what we're building up to, the adaptive bitrate streaming. That's what we want to talk about eventually. And this is all about AO2. We've talked about all the learning objectives for homework 3. We've talked about AO1 for homework 3. All of today is all about getting you through that AO2, which is by far the hardest part of the homework. Actually, I don't know. I don't even know if that's fair. I think it's the hardest part of the homework, but parsing multipart has its own tricks and stuff to it, its own difficulties. I think it's harder than that. I don't know if it's fair to say by far harder than that. But let's talk about it. I guess I don't need my laptop sitting here. Oh, you're killing me. This is how today's going to go. Do I have to have the mouse on it? I don't know. All right, so this is the first issue that we're going to solve. We're going to solve 2 issues today. The first one is, based on everything that we have so far, what we've talked about so far, we're going to have users upload videos to our app, or maybe we're just hosting our own videos, but we want some video playback on our app. So we're hosting these large MP4 files. They can get very large, especially when we want high quality. So we want to host a 4K video. We want to host a 4K video on our app, and that's going to be a very large file. It's going to take quite a bit of bandwidth to be able to download that file, and it might be hundreds of megabytes, depending on, of course, the length, the frame rate, and all of that stuff, the compression ratios and everything. So to visit our page, to view this video, somebody visiting the page has to download the entire MP4 file and then start playing the file. So they're going to have to wait for quite a while before the page even loads, before that video even does anything, plays the first frame. And even if the user goes to a video, how often have you went to YouTube, pulled up a video, watched the first 10 seconds of it or less, and then navigated away and said, I don't want to watch this anymore. Those users have to download this entire video. That's a lot of bandwidth. That's a lot of processing for your server, a lot of bytes to send, just a lot of work that has to be done to be able to get that to happen. This fan's really distracting. I need IT support. Nicholas, email every IT person. I don't even know what piece of equipment it is, but something's melting in there. All right, so that's the problem that we have. And we have several solutions. One solution is to have the browser only ask for part of the file. This is a mechanism that's supported by HTTP. It's in the HTTP protocol to use this range header. What the browser can do is request just a chunk. Oh, and I can't really point to things the way I like to. Just a chunk of the file and ask for part of that file, maybe 2 to 10 seconds, somewhere in that range, to be able to play just a little bit of the video at a time. And then the nice part of this, and this is ultimately what we want, serve chunks of the file. The user who visits the page and just views the first 2 seconds of the video and then leaves, well, they only have to download one chunk, so they get the minimal amount of bandwidth has to be used, the minimal amount of server processing that needs to be used to be able to accommodate that viewer. And if a user skips to the middle of that video, no big deal. We don't have to download half of the file to get to the middle. We just start requesting the bytes for that middle of the video and just never download that first half. We download the first few seconds when they load the page, then we start downloading right in the middle. This is really what we want, and we don't ever have to load the entire file. And playback starts right away. You go to the page, bytes start downloading, download 2 seconds of the video, and start playing that 2 seconds while the rest of the video downloads. That's what we like, and we get some good buffering qualities from this. The range header supports this in HTTP. The browser can ask for a specific range. So we host one MP4 file that's hundreds of megabytes, maybe even gigabytes large. And the browser can request just part of that file with a range header. They're going to send you a request and say, give me the 10,000th to 20,000th bytes of that file. And then our server will pull just those bytes of the file and just serve up those bytes. So we're limiting the bandwidth, we're limiting our disk I/O, we're limiting a lot of that to be able to get just those bytes. Our server in this case would respond, we're not going to do this on the homework, but this is a solution. We would respond with a 206 partial content and a content range header. Content length is just the same as it always was. It's the number of bytes that you're sending. And also this content range header, which is going to contain the range of bytes. So if they requested 10,000 to 20,000, I'm going to return content range 10,000 to 20,000. These are the bytes of the file that I'm sending, and the total length of the total size of the file. So we want to let the browser know what the total size is, so they can throw that in their algorithms and decide which ranges to request in the future and how to chop up this file for them. If we're sending the entire file, the first to 500,000th byte here, and then slash whatever the largest byte is, but remembering that our indices are 0 indexed, so 1 plus the final index is the size of the file. So this is definitely something we could do. Maybe someday if I'll put this on homework. Probably not, though. This is a bit much, a bit of a lot going on there. And so there are some downsides. One, it's extra complexity. You have to code quite a bit to be able to support this range header. Not too much, admittedly, but enough that it's kind of a pain. Actually, maybe not. But it's extra complexity to be able to support this feature, communicate with the right headers, and let the browser know what you're doing. The browser has to know if you even support the range header. So in your first response, you have to have the content range header decide how much of the file you're going to serve, and then have the content range header to tell them, hey, this is how big the file is. I'm only giving you the first 10,000 bytes right now, but here's how many bytes there are total. So if you want more, request more. But it relies, my biggest issue with this is it relies on the browser to a significant degree. Everything's implemented in the browser. If the browser doesn't even implement this range feature, that browser is just going to request the entire file anyway. So there's no robustness to this because we rely on the front end. Every version of every different browser, everything's going to do this slightly different. We can optimize to Chromium to get most of the users, but then a Firefox user or I almost said Opera. Well, an Opera user too, but that's Chromium. A Safari user is going to come along, and Safari is going to do everything wrong, and they just won't have as good of an experience. They might be requesting the whole file. Who knows what they're going to do? Okay. So not exactly what we want with the range of bytes. So we're going to do something a little bit different. We're going to manually do this on the server side and get that robustness that we need. We're going to tell every browser, no, this is what we're going to do. This is how you're going to request these video files. So we're going to, not manually, we're going to use FFmpeg, but we're going to take that video and chop it up into separate files and then ask the browser to request each file as needed. So the browser is going to say, I would like the first file of this video when you first visit the page. We'll serve up the first file of the video. That's the first chunk, like 2 to 10 seconds of the video. And then when they're ready for the next one, they'll request the next file. So we're basically forcing them to use the range header. Then we don't have to rely on anything from the browser. We don't know which, some browsers might request an hour at a time of playback. Some might request 1 second at a time. We don't want to rely on that. We're going to specify what the time length is. And it's going to solve all of our problems. Somebody only watches the first few seconds of the video. Well, they only download the first, maybe just the first segment, maybe the first couple, and then they leave, and we don't have to serve up anything more. We don't have to think about how much we're going to send. They're just naturally only going to request the first 1 or 2 segments of the video. Somebody skips to the middle of the video, well, no problem. They just start requesting those middle segments of the video. No problem. Everything's handled. All the problems are handled that we proposed with this solution. And then the big question, how do we do this? So there are 2 major competing formats. There's more if you want to consider some others, but these are the 2 major ones out there that we can use. Might as well bring up one of the other ones. There's YouTube's protocol that they use specifically for YouTube. I believe that's not an open protocol. I believe it's proprietary, but I could be wrong on that. But these are the 2 that we'll talk about anyway. HLS and MPEG-. So here's my just quick overview of the 2, and then we'll get into the details of each of them. HLS, and by the way, for those of you who have looked at the homework, I updated AO2. It used to say you have to use MPEG-. I did change that to give you the choice of which one of these 2 that you want. My personal opinion keeps swaying back and forth between the 2. Right now I'm on HLS, so it didn't make sense to ban HLS and say you have to use MPEG-. But here's the kind of pros and cons of my quick comparison. HLS, HTTP live streaming. This is developed by Apple, so it loses some points right away on my book. But even despite me using a MacBook Pro, which just restarted on me, so I can hate Apple today for sure. This only supports H.264 encoding, which is the MP4 encoding for video. And it has widespread adaptation. This is the biggest point in favor of HLS, is it's going to be supported pretty much everywhere. You can get HLS to work anywhere you look. It's going to have some support in some way, any device, anywhere you go. And the spec is freely available in an RFC. I've gotten so used to RFCs, I never even consider what the alternative is until MPEG-. So MPEG-, developed by the MPEG group and supports any video encoding. MPEG- is more of a container for audio and video, any media content, and less of a format restriction itself, where HLS says, nah, you're going to use MP4 encoding. This says, nah, we're just going to host whatever. We're going to contain whatever data you want, and then you can specify the encodings. Like part of MPEG- is you specify what the specific encodings are for that specific video or that specific piece of media. One point against HLS, I don't know, maybe I shouldn't be too opinionated on this, but there's no support on Apple devices for MPEG-. Apple says, we built HLS, our devices support HLS. If you want to have video on our devices, you're going to use HLS in a very Apple kind of way. They seem to want to control everything. And they just cross their arms and say, we will not add support for MPEG-. We don't care. We came up with HLS. That's what you're going to use if you have an Apple device. So if you're hosting video and you don't want to outcast everybody with an Apple device, specifically iOS, like like my laptop, I'm just going to run a browser. It's whatever the browser supports. But if somebody's using Safari, I suppose, no, that doesn't make sense either. But on iOS devices, you're not going to have native MPEG-dash support. And the one that really gets me is the spec is not in an RFC. With the internet, I'm just used to everything being an RFC. It's open and free for everybody. It's published with an ISO, this ISO number, which you can get for the low, low price of $245 just to see what the frickin' spec is. This irritates me to no end. I can't even put a link on the course website to say, here's where the spec is, where you can get all the details. I had to put a link to the Wikipedia page because they're hiding the details of what's supposed to be an open standard. It frustrates me. But anyway, the fact that I couldn't look at the actual spec without spending what I would consider an absurd amount of money for a spec for a document. Anyway, so that's the pros and cons. You can make your decision of what you like better, whatever. I'd say HLS is probably the way to go. Despite being Apple and liking to lock everything down, they did open up the spec with an RFC, so it seems like they are trying to just say, hey, we built a good thing here. Why don't we all just use one standard? And kind of forcing it, but you know what? It's a decent standard. So, okay, so HLS, what is it? We're going to split the file into these .ts files, which don't actually, I put it on the slide, but it doesn't actually have to be .ts literally. That's what the output of FFmpeg will give you, but you can use different formats, different file extensions anyway, as long as they're encoded using the MP4 encoding, as long as they're that H262, oh, I got the number wrong there, 264? 264. As long as they're the H264 encoding for MP4, then you're going to be fine with it. And then one index file, an M3U8 file, that's this file right here. This is my directory structure. And then this file here is going to have all the information about which each segment is encoding. So each of these TS files are going to have one portion of the video, and this is going to tell us which portion they are. So like space2.ts has 8.34 seconds of playback, and if you do some math, you can figure out what exact 8.34 seconds of playback that is. So in your browser, you would host this file. Your server is going to host all files. But this file is the file, the index file is the one that you'll set as the source of your video. The browser is going to take that index file, look at all the information, parse all that information, figure out exactly which files compose this whole video file. It's going to compute the total playback time and any other information it wants to display to the user, and which I guess is just total playback time in this example. The total playback time, and then start requesting the TS files as needed. If a user skips right to the middle of the video, it's going to use these timestamps to figure out which exact TS file they skip to and request that exact file from your server. So from your perspective, you're hosting all of these files because anybody getting the index file is going to start requesting these TS files on separate requests, bless you, on separate requests. So you're hosting all the files, but it's the index file that you set as the source of your video so that the browser can get all of the information about that video and which segments it should request at which times. So that's, in a nutshell, the HLS format. And for using FFmpeg to convert to HLS, the format is -F HLS. Oh, man. HLS, pretty straightforward, easy to remember, HLS. The one thing that you have to be careful with is HLS, it's HTTP live streaming. It is made for live streaming, and FFmpeg takes that seriously. FFmpeg will only save the last 5, I don't know what I'm pointing at, there it is, the last 5 files in the index file. So if you have a large video and you use this command, well, not this command because I have the fix in there, but without the HLS list size, if you don't have that parameter in there, that argument in there, then your index file will only contain the last 5 files for that stream. for that video. So to override this, we do HLS list size 0, 0, which of course very intuitively stands for infinity. This will save every single file in the index file. So the entire video is going to be encoded in that index file, and you won't just have the last 5. Even if it has just the last 5, all the TS files will still be generated. They just won't all be in your index file by default. You could, of course, add them manually if you wanted to, but they won't be in your index file. The use case being if you are live streaming, somebody requests the index file, they don't want to start at the beginning of the video, they want to start close to live, so only the last 5 files. So make sure you have this parameter. Long story short, make sure you have this parameter or else you're going to be missing a large portion of your video, and during grading we'll test with longer videos to make sure you have that parameter set if you're using HLS. Just don't forget to have it in there. But we're effectively building a VOD site, so we're going to have that parameter in there to set that to 0. Okay, MPEG dash, a little more complexity here. So let's talk about MPEG dash. This uses an MPD, media presentation description file, which is an XML formatted file containing all the information you need to know about this video. About this, I keep saying video, but it's any media. Can be just audio files for what it's worth. So this file is going to be the index file similar to the M3U8, but it's going to be an MPD file this time. And you're going to host all of the chunks of the video and also the MPD file, which is going to store the meta information about that video. So this is going to tell us exactly which files to download, which ones to download at which time. I'm using too many words here. It's doing the same thing as the M3U8. It's an index file that tells you all about the files that should be downloaded, should be requested to be able to get this whole video stitched together. And the file doesn't fit on one slide. Well, it does fit on one slide, but not that one. So here's the entire file in its entirety. And we have all kinds of information here. The bandwidth, the resolution of the video, the initialization file using this representation ID variable. That's going to get the ID from right here. So ID is 0 for this specific example. Init stream 0.m4s is going to be the initial file that it wants to download to start with a stream. And then this chunk stream representation ID, which again is 0 in this case. And then whatever number you're requesting, dash whatever number you're requesting, .m4s, and the starting number, starting index 1, gives us the information that we need to be able to request the right file. So we're starting with this initial file, and then any chunk stream 0, 0 for the representation ID. And then starting at index 1, and this one happens to go up to 14, that's telling it how to get these files, how to request these files. So a lot of information about the content. We can start seeing MPEG dash has a lot more information here. Part of that is because it supports more codecs than just the H264. It supports anything, so a lot more information has to go into this file to say what it's carrying. Plus it's XML, so it's naturally just kind of redundant. Can I speak about how mid-semester evals were handled? If you didn't get LO1 on homework 2, you got an MU for the mid-semester. I made it pretty straightforward. If you didn't even finish LO1 on homework 2 before the expected deadline, you're pretty far behind. Like the expected deadline, you should have all 5 objectives done. If you didn't even get through LO1, it's a pretty easy decision in my eyes. That's why I posted them right after homework 2 expected deadline. All right, and your transcoding command, its format is dash, so not MPEG dash, one little variation, but just dash. That's usually how MPEG dash is called, just dash, instead of saying MPEG dash, MPEG dash, MPEG dash. I'll say that, but dash is usually what it's shortened to. And there's no concerns about only storing the last 5 segments or anything like that, just dash F dash, and that's going to generate a all those files, all the files that you saw in the previous slides. That's going to be generated by this one command. Oh, yeah, I'm glad I looked at the slide. I have to mention this one. If you are using MPEG dash, so if you notice, if you're watching real close, for the HLS, FFmpeg named all of my files based on the file name that I specified in the command. So I said space.m3u8 right here as the output file, and then it takes the prefix, the file name without the extension, and uses that in all of the other files. So if I have some naming convention, I say generate this naming convention.m3u8, and it's going to name all my files according to that. MPEG dash does not. I said output space.mpd, and it gave me this naming convention for all my files, which will cause naming conflicts if you're transcoding multiple files. So if you are using MPEG dash, it can help to put each video in its own directory. Create a directory for that video, and then output to that directory, and that's going to help you avoid all those potential name conflicts, or tell FFmpeg to use different names. I believe there's a way to override that. I didn't do it myself, but just use directories, in my opinion, is the easier solution. But either way, you have to avoid that naming conflict. If you're using MPEG dash, make sure you can support 2 videos being uploaded, because once that second one's uploaded and overwrites the other files from the first upload, it's not a very usable site. Okay, any questions so far? All right, I'm going to keep plowing through. We lost a lot of time at the beginning, so I'm going to keep going through then. If there are no immediate questions. Adaptive bitrate streaming, that's what we're actually after. That's what we need to get all this to build up to adaptive bitrate streaming. So what's the problem here is that we have this video hosting site, we're hosting a video, and we have this lovely video, we put a lot of time into it, or maybe it's a user uploaded, but whatever the case, we want to host that video and make it look real good. We want to make it look sharp. So we're going to host this video, we're going to chunk it up and do everything that we said, but we're going to host that at 4K. We want to get the most resolution out of our video. We might even go up to 60 hertz. We want the highest quality possible for our video. Maybe we're even going up to 8K and hosting the video there. The problem with this is going to take a lot of bandwidth to download that video, and not everybody's going to have that bandwidth. Somebody on edu Roam on a bad day is going to have lots of buffering, stuttering, or maybe the video just doesn't load at all. If you have slow enough Wi-Fi or mobile data that you're using, the video might just not load ever. You might be waiting a long time just to see the first half a second of that video. Pretty bad experience for somebody with low bandwidth trying to watch this video. Not really going to work so much. So what we need is a solution that allows users with slow connections to still view your content, but users with high-speed internet should view your content with high quality. They should see the highest quality of video. And this is what we see, like as a user of the internet, you see this every day, every video you watch. I mean, unless you always have high-speed Wi-Fi. You'll see this a lot in your, actually I take that back. Even when you first load a video, a lot of apps, the first few seconds of the video will be really low quality as it starts figuring out that you have high-speed internet. So you see this every day. Adaptive bitrate streaming. This is what we do. So instead, what we're doing here, what we want to do is instead of hosting that one file, or maybe it's HLS or MPEG dash where we have multiple files, we're chunking it up, we have an index file and everything, so maybe multiple files, but one version of the video, we're going to have multiple versions of the video at different resolutions, which each will have its own bit rate. So each resolution is going to have some bit rate requirement, some bandwidth requirement that you need to be able to watch the video at that quality. We're going to host all those resolutions of the video, and then the user, their browser is going to decide which one to download. If the user has high-speed internet, the browser is going to jump up right to the highest quality and start downloading that 4K or 8K video version of the video. And if they have some crappy internet, their Wi-Fi is down, they're going to go down the quality list, and they'll still be able to enjoy your content, just at less quality. They might have to look at it at a much lower quality. It might be very pixelated and everything, but they won't be completely shut down. Watching a low quality video, I mean, some of you might disagree, but watching a low quality video is better than watching no video at all and just having a blank player that won't do anything. But that's what we want with this. And with HLS and MPEG-, we already have the video segmented. We have it split up into smaller chunks. And then we're going to create those chunks at various bit rates and then host all of those chunks for every bit rate for our video. What this does is lets the browser switch between resolutions seamlessly. So if we hosted like 4 different MP4 files and they requested whatever MP4, maybe they're using the range headers and stuff like that, that can get tricky to switch between resolutions. But with HLS or MPEG-, switching between resolutions as needed is going to be seamless for the end user because there's going to be a chunk for each quality for each 2 to 10 second segment of video, and the browser can just keep switching between them at will. So you're enjoying a video, you visit a site, or your user's watching it at 4K, everything's fine, and then all of a sudden everybody starts using the Wi-Fi and your bandwidth tanks. The browser's going to see that and say, okay, let's start requesting the 480 chunks of this video. You're going to watch at 480 for a while. Your Wi-Fi lets up and finally gives you bandwidth again. Browser's going to see that, notice that, and start going back up to the 4K, and everything's completely seamless to the user, pretty seamless to your server as well. You're just hosting all of these files and serving an index file, and then letting the browser decide when to request which chunk at which quality, and you don't really care if the browser's switching between them. You don't have to keep track of that. You're asked for a file, you serve that file, and that's it. The browser does everything else. Okay, so how this works in HLS. HLS, I think, has a cleaner solution to this one, is you can have multiple M3U8 index files and then have one main top-level index file that refers to the other index file. So you can nest these index files, which, spoilers, we're not going to be able to do that with MPEG-. But I have one top-level index file. That's the one we're seeing here. And it's going to refer to the other index files, the other 3 index files. So this media1.m3u8 is an audio track. So this is my audio track named audio1. And then I have 2 video tracks at 2 different resolutions, at non-standard resolutions. This is a vertical video. At 2 different resolutions. And it specifies this uses this audio. So we're saying use the audio from media 1, use the audio from media 1. But each one of these streams, each one of these video streams is going to use its own media file. So media 0 and media 2 are my video index files, and then media 1 is my audio index file. So we split up the video and audio into 2 different tracks, and the browser will stitch those together. It'll ask for some audio. It'll ask for the video at the bandwidth that it wants, and we have this bandwidth is 10 times more than this bandwidth, which doesn't match the resolution exactly, but 10 times more, so it's going to request whatever one fits the available bandwidth, but it only has one choice for audio track, so it has to use that one. And then each of the media 0, media 1, media 2, those will look like the files that we saw before, which references all the TS files for that, or not necessarily TS, but all of the MP4 formatted encoded files containing the actual data. So that's HLS. Since index files and HLS can nest, pretty simple, pretty straightforward. Okay, MPEG-, a little less straightforward, in my opinion. At the very least, I needed more slides to talk about it. So MPEG- in this big old XML blob, this XML format, takes a bit more, and these can't nest. These XML files can't nest, at least to my knowledge. I'm pretty sure they can't. But we're going to specify everything for one video in one single XML file. We're going to do this in multiple layers: period, adaptation set, and representation. So a period, for our purposes, we only need one period. So if you're using MPEG- for your homework, for your AO2, just one period is fine. But you can think of these as multiple chapters of a video, or if you think of like YouTube's, they do call them chapters, don't they? But you can think of different chapters of a video. If you want to split your video in up like that, if that makes sense for your use case, you would use periods like that. I don't want to talk about periods anymore. But this file only has one period. There were no other periods in this one, in this example. Each period can have multiple adaptation sets, and this represents the different tracks of this media file. So this specific example has two adaptation sets, one for video and one for audio, similar to the HLS file, that top-level index file that we saw. We have two adaptation sets. We might have a third one for closed captioning. We might have multiple audio tracks if we want stereo or surround sound. This would just be mono sound for this one. So whatever we want to represent, we can represent that with multiple adaptation sets to have multiple tracks all combining for one experience. Or maybe we only want an audio track. Maybe there's no video to this one. It's just audio only. We would just have an audio adaptation set. And then finally, the representation. This is the bit that we're really interested in. Each adaptation set can have multiple representations, and this is where we're specifying our multiple bandwidths, our multiple resolutions through multiple representations. So each adaptation set can have multiple representations, and you can see the audio track on this example just has one representation at 128K. Oops, that's the wrong one. At 128K. But we have two videos with different resolutions, and one at 480K and one at 1 megabit per second. So the browser is going to decide which representation it's going to request at which time, and then each representation is going to have its own set of files. Oops. Each representation is going to have its own set of files. So before we just saw an example of just one representation. This one has three representations. So the representations 0 and 2, 0 and 2, these are going to be my video representations. This is my low bandwidth video. This is my high bandwidth video. And each has its own init stream, its own initial file. And then representation ID 1, this is going to be my audio track here, all the ones with its own init stream. So when you convert an MP4 to an MPEG-, you're going to get all of these files when you use multiple representations. So for AO2, this is the expected workflow. One, you're going to choose what's your favorite, HLS or MPEG-, or whatever one you think will be easier. Whatever your decision-making process is there, choose one of them, and then write code that's going to programmatically convert an MP4 into that format with all of the files required for that format, and then host all of those files, serve your video with the index for the representation that you had. And please don't do anything manually. There's no expectation that you're going to do any of this manually. You're going to send commands to FFmpeg that starts with an MP4 and ends with everything that you need. So we went through the format of the files, at least at a surface level. Do not write those files manually. I mean, if that's what you want to do, if that's what you're into, knock yourself out. But that's not the expectation. The expectation is that you do your research, look up FFmpeg commands. I showed you just the basic ones, but find the commands to be able to generate multiple encodings at different bit rates and stitch them together in a single index file, and then host that index file, and then let the browser choose between the resolutions. Okay, we have one last problem, which we can get to quick here. I do not want to replace text. Is that the built-in video players in most browsers don't support either HLS or MPEG-. which seems like a pretty big problem. And during grading, we will not use a browser that natively supports these formats. So we have to do something a little extra. We have to get a third-party video player. You can use whatever you want for this. I'm going to show an example using Video.js. I think it's the easiest one to use, and it supports both of these formats. So only one video player that we have to worry about. Here's an example downloading it from a CDN. I'm going to get it from this CDN and get the style sheet and the JavaScript. And then use this data setup and class to be able to tell the browser, hey, use the library, tell the library to do its thing, treat this video element as a Video.js video player, and then for the source, I can use either my M3U8 if I'm using HLS, or my MPD if I'm using MPEG- for my source. And then I get one video player that's consistent. I'm not using the browser's default video player, so it's consistent no matter which browser somebody is using. They're going to get a consistent experience whenever they visit your page. Like you can visit YouTube on your phone, on any browser on your laptop. It's going to be the same experience everywhere because they're not using the browser's built-in video player. And live streaming we won't really get to. All right, we made it through with technical difficulties and all. We made it.
I happen to have a key that works on this podium.
I hope there's nothing wrong with my laptop. But that fan was annoying. Among everything else, I'm trying to deal with this fucking fan blasting in my ear. What's up?
I was just wondering if you got my email. I understand you're probably really busy, but I just wanted to make sure.